This is another update video for the Pocket Computer Universal Interface, or PCUI. Another more of a behind-the-scenes video. Not anything new in terms of a new model just yet that's ready to be announced for support with the PCUI. However, this actually is a little bit, again, I mentioned behind-the-scenes video, because I, in the past, recently published a video going over and a demo going over the support in the PCUI for the Casio PB-770 as well as the Casio PB-700. So the 700 came out first, and then it was followed by the 770. And this video goes through, how can I say, a bit of a deeper dive into the cassette protocol for both models. And the reason for that was really getting the ASCII mode file transfers working on both of these models. It wasn't reliable. It wasn't really working all that well, including even in binary mode, the normal transfer mode to and from cassette. So when this is connected to the PCUI, you can save your programs to the PCUI, which in turn saves to an SD card. You can then take the PCUI and load the same program or programs back into the Pocket computer. So that's the part that was unreliable. It wasn't consistently successful. Maybe 1 or 2 out of 3, a little more than half of the time would just fail. So that's not, I wouldn't consider that acceptable in terms of proper support. So while the rest of the functions and features worked great, the plotting, emulation, and some of the other features here, the printing features, worked perfectly, I wasn't happy with the way that the cassette loading was working. So in this video, I'll demonstrate, again, behind the scenes of how I kind of go about investigating how these things work. It's not, there's no protocol guide out there for these models or any of these old Pocket computers. Some have written some articles or published some information on these, not these particular two, but they work in a similar way. So if you solve, for example, for the PB-100, another Casio line of Pocket computers, chances are some of that experience you can use on a later model. But still, it's not like we can consult a textbook or a specification or integration guide here. So we have to do a little discovery on our own. So this video will go through how I set up a test fixture to investigate the protocol a little bit more closely, what the fix was, what the cause perhaps of the issues were, as well as why I cared so much about getting ASCII mode or the cassette loading and saving working in the first place, specifically with these two models. So let's get started. So I have the Casio PB-700, same as the PB-770 for the most part. A little bit more basic commands on the 770, more memory capacity. And what I'm doing is troubleshooting the cassette loading and saving from this to the PCUI. So what I have connected here, I've got the printer support working just fine. It's actually very easy compared to the other models, the other previous Casio models. This actually puts the bits directly onto the bus for the printer. So that protocol is a lot easier to implement, so the printing works just fine. The thing that is not working, it's not working well, reliably enough, is the cassette loading from the PCUI back to the PB-700. So what I've done is, I thought I understood the protocol. I think I understand the protocol. I don't understand the framing so much. So what I'm connecting here is a test harness, if you will. So I have the 15 pins from the PB-700 going into a breadboard here. This should look familiar if you've seen the previous video on the PB-100 troubleshooting. I then have those 15 pins going out to the Casio FA-10. So this is the plotter printer and cassette interface for this particular model and the 770. And I had to get creative here and use the DuPont connectors, taking the plastic off and using just the connector, the bare metal connector, and then putting some shrink wrap over there so they don't short out because they're very close to each other. So there's 15 pins going in there. So effectively I've connected this straight through to the FA-10. However, I am listening in on a few of the bus lines on this logic analyzer here. So that is connected through this buffer. So I've selected to sample the clock, chip select, or chip enable 2 operation, or OP, and data 4. So what I'm doing is I am saving, for example, typing save over here, a program, and then recording it to cassette. While I'm doing that, I'm capturing the bus lines that I'm interested in on the logic analyzer. And then I'll rewind the tape, play it back as I load it back into the Pocket computer, again, listening to the certain lines on the bus that I'm concerned with the logic analyzer. So I'm doing that in binary mode first, a save and a load, capturing both of those. And then I'm doing ASCII mode, because ASCII mode is where things broke on this. So it uses a different framing. Basically what ends up happening is, instead of sending or saving and loading tokenized BASIC, this model can save and load ASCII mode. So it just sends the characters themselves, the actual program listing, rather than the tokenized format, which sounds easy. When it saves it to cassette, this does something weird. In between each frame, I can hear it stopping the motor. I hear the relay clicking, stopping the motor on the cassette, or the remote cassette if you have a remote cassette attached. It stops and starts the motor really quickly. And it's doing that at the end of a frame, and then so it turns the motor off, turns it back on really quickly, and then there's leader bytes in there. It's just the solid tone. So I read some documentation others have put together that hint that perhaps that is causing it to skip over a byte or something to that effect. But I'm not really buying that so much, because it's in the leader part of the next frame. So it's almost as if the firmware, or the firmware here is saving each line in ASCII mode, each program line, as if it's saving a program each time. So it's doing something internally, like, several saves, one for each line, which causes the motor to briefly stop and start on this. It doesn't appear to affect save and load in ASCII mode. I do not have the remote wire connected from here to this tape recorder. I'm just using one connection, so I'll switch it between ear and mic as I'm loading and saving. So I was able to save and load binary and ASCII, same thing, back and forth, and I've captured a total of 4 captures with a logic analyzer. So I'm going to run that through a Python script that's going to summarize that, given the framing and the protocol, that, as I understand it anyway, and see if I can spot anything that is unaccounted for, that I missed. And connecting this to the real hardware and listening to what's going on should, like as with the PB-100 series from Casio, shed some light on some missing details, and that should then give me some information to update the firmware for the PCUI. All right, so a couple of things, summary of what was discovered on the cassette interface troubleshooting. So again, the printer feature, the printing feature on this model worked just fine. Nothing wrong with that. That was actually far, far easier than the Casio PB-100 series. So that one, I think I mentioned that for the printer support, the PCUI does not have to reach into the memory of the PB-770 or the PB-700 and go fetch the data for printing like it had to with the PB-100. That's how that printer works, that series of Pocket computers. This one presents the data on the bus. In fact, there was a model of, there's two, the FA-10, the FA-11, I believe, which had the printer plotter and either a micro cassette or a full-size cassette, depending on the FA-10, FA-11. That also had a cassette adapter. However, Casio had released a Centronics or parallel port docking station or dock that would connect to this 15-pin connector and provide a standard parallel port. So it would work with more modern or standard printers. Modern is kind of a relative term, I guess. Standard printers as opposed to a printer plotter or something that's specific to these models. And that is a very rare device to find. I've never seen one on any auction site. So that alone kind of led me to believe that the printer interface is far easier. And there's also a schematic published for that. So somebody had reverse engineered one of those. So very simple device, just a few basic logic circuits, and you could actually make a hardware version of that yourself. So that was kind of proof that this interfacing with a printer is very easy relative to the other Casio models. So let's take a look at what the fix was. So in the prior segment, we just saw the PCUI was kind of out of the picture. We had our infamous, let's see, bus capture process going on here with the FA-10 and the PB-700, and learned quite a bit from that capture. A couple of things were fixed. The ASCII mode, watching the transfer happen, it actually kind of showed me the segment. I was correct on the theory that the PB-700 expects every line of BASIC and ASCII mode to be sent with an open and a close for the transfer, something similar to that. However, there were some other details that I had not accounted for that the capture had showed, so that kind of solved that problem. The other thing that the capture showed was that the timing and pacing was quite different than what I had expected or assumed. So that timing and pacing between each word and between each line of tokenized BASIC, I should say, was rather important. So the PCUI here was going quite a bit faster than it should have. So on occasion it would cause this to basically give an RW error, read-write error. I couldn't keep up. Especially with tokenized BASIC, you have to give enough time for these to receive, just like with a Sharp PC-1500, enough time to tokenize that line of BASIC. Worst case scenario is a full line of BASIC, the maximum line possible, not just a few keywords of BASIC in the line, but say a full line of BASIC, the maximum allowed with a whole bunch of keywords in there. And relatively full memory. So, you know, as it gets to the end, it may have to, may take a little bit longer time to tokenize a line, perhaps. So that's about 3.8 seconds, roughly, if my memory serves me. That was what was observed. So that's quite a long time. So let's get started in kind of going over the fixes. So the first one was the ASCII and bin mode read-write issue occurring. It was occurring at random intervals. So if I were to load a very small program, a few lines, it was fine. There was no problem. On occasion, I'd see the RW error. Now, when loading a very large file, like the Globe program, for example, which I posted on an article with that program running in a previous video, I've also demonstrated that. That program isn't incredibly large, but it's a good-sized program to load into this pocket computer to really stress test or test the reliability of transferring a larger program. So that program in ASCII mode, that takes about almost 20 minutes to transfer. That's a long time. So if I can get through loading that several times in a row, maybe 10 times in a row, then I would say I've gotten it narrowed down and the problem is solved. And I did. I was able to get that done. So I'll just do a quick load of that. For example, we'll do Globe. I'm not going to actually wait the full 20 minutes here on this video, but what I'll do is I'll press the enter key here, and then the menu is going to come up to select the program to send, and I indicated ASCII mode, so I'll go ahead and hit that. And so what's happening now is this is sending the header, so we can see that the header appears here. It's a program file in ASCII mode, and that's the name of the program. And we could see something interesting here, and that the LED indicates calculator transmit, so that's us transmitting to the calculator. And what we're noticing, or the pocket computer, is there's a period where there's a transfer occurring, there's a period of leader bytes, and then a stop, a wholesale stop, or a long gap. That long gap was the tokenization, the gap that we saw in the cassette, the real cassette interface, where we're allowing the calculator to tokenize that line. So that LED, the other thing is it's actually blinking with the transmit, whereas before it was a solid light the entire time. So that is a hint, if you can guess what the fix was here. There was some jitter on the framing from the PCUI to the pocket computer, and it was on occasion causing the read-write error. This would finally just give up. That ended up being a, believe it or not, a simple mistake on my part. Interrupts on the pocket computer universal interface on the PCUI. There are a couple of things that are happening in the background in any mode, when it's sitting here idle, when it's transmitting, when it's receiving, when it's in printer mode, doesn't really matter. Wi-Fi is disabled, so we don't run any Wi-Fi commands for these calculators except when in print mode, not in tape mode. So in cassette mode, we need the full attention of the CPU. This particular interrupt service routine that's running needs to be very, it's very timing sensitive. So the fix was, while sending in cassette mode, whether it be binary or ASCII mode, we were polling in a background loop the LED queue to light the LEDs or to update all the statuses. And that, it was stacking up several entries to turn on and off the LED, for example, during each word that's transmitted. And it was processing that in the background when it had time. The problem is I didn't collapse all those entries in the queue. So what ended up happening is it would literally just, this LED, the LED is, these LEDs are actually connected through a port expander. These are I2C serial addressable. So from the Pico out here, this is on the same I2C bus as the OLED display, as the other port expanders. It takes, it's not an incredible amount of time to address this once and send a byte of data, which updates the LEDs. That's not the issue. It's really sending, say, 20 or 30 bytes in one go. That's a problem. That, in that queue, it had that many entries, if not more. And you wouldn't really see it visibly on the screen or on the LEDs. You wouldn't necessarily see that. But that was enough to throw off the timing in such a way that the PB-700 gave up on occasion. I'd have 1 out of 3 loads that would work correctly with a large program. So we're not really updating the display. That's already somewhat intelligent from the firmware here that I've written. So unless there's a display update, this never gets updated. So it just sits there. No I2C update needed there. Updating the OLED takes a long time, in relative speak, right, compared to the LEDs. This is a single byte that's written on the I2C bus. This would be, I'm just throwing a number out, maybe 1,500 bytes. I could be way off, but in other words, the bytes may go across the screen, you know, vertically and then horizontally. So maybe 100 bytes or something like that, 128, I can't recall. But that takes a long time and relative to an LED update. So I disabled the normal queue processing and processed these a little bit quicker so that they don't pile up all at once. And there was also some blocking that was going on in the way I wrote the buffers and the queues that work in here. It was just bad programming on my part. I was overly protective of critical sections of code, so that if a consumer was pulling a byte out of the queue for processing or pulling an event out of the queue, it was locking and then the producer that was putting the event in the queue was also doing the same thing, which is good practice to present or prevent race conditions. But again, that in the C SDK for the Pico 2 and the Pico, that disables all interrupts. And on something like the Pi, the Pico here, that's bad. That can trash any timing you have on even the highest priority IRQ. So if that's not necessary, don't do it. That was a lesson learned. So it wasn't necessary. I had single producers, single consumers on several queues, totally unnecessary. It's overkill. So that was trashing the ISR serviceability there. There was enough of a delay where the PB-700 didn't like it. So that was that issue. Now again, part of this is probably not the best design on my part to start with. For the PB-700 cassette interfacing, I'm not using a PIO state machine, so that's probably not the best choice, but this just works fine. There's this, you know, properly handling the queues and things like that, LEDs, was a good fix. So that fixed the jitter, and that fixed both ASCII and binary mode. The other issue in ASCII mode here is that the end of file after transfer, this would show the main screen, and then this would just be sitting here on the loading screen, and you'd have to press the break button, and then the Pocket computer, if I did a list, it actually did receive all the data. It just the PCUI was not sending the two end of line in a row to close the transfer. And it wasn't end of line. I think it was an end of file, two end of files in a row. The other issue is in ASCII mode, we were dropping lines. So I would get a successful transfer. I wouldn't really pay attention to it too much. And then I would send the same file back to the PCUI and compare them byte by byte to see if they're similar in ASCII mode. And the file coming back was about half the size of the file that we sent to the PB-700. That's not good. So it wasn't the send or the receive over here that's the problem. It was the transmitter from here to here. I did a list here, and about a third of the lines ended up showing up, even though we were sending them all. And that was just an issue with the close and then open after each line, getting that to work correctly. So as you can see here, we're loading the Globe program. I'm not going to let this go for 20 minutes for this video, but you'll notice that I have the logic analyzer in this setup now connected directly to the PCUI, and only 5 lines, or four different lines and then a ground. This connector is a CMOS level connector, like I use this on the 702P Casio, their first basic programmable pocket computer. It operates on a 3.3 level, 3.3 volt level. So I am able to tap off of, for the PCUI and the PB-700. I happen to be using the same GPIO pins that there's some overlap with this level. This is before this level shifting buffer here, this connection here. So this is the 3.3 volt level. So this is effectively the same as tapping off of the Pico pins directly. This is just a lot more convenient with the DuPont style connectors there. They just snap right over the pins. So I have this going directly out to the logic analyzer. This doesn't pull it down enough. The bus doesn't get pulled down enough. So I'm able to capture and record the PCUI sending data to the PB-700, and I'm able to capture that and just make sure the timing is looking correct, close to the real tape protocol, and other things like that. So I have that connected still for the time being. All right, let's connect lessons learned from the PB-100. The PB-770 is an updated version of this model, has a few more basic commands, and can be outfitted with more memory. So let's connect that model and make sure that it works just as well as this one. Okay, I have the PB-770 connected with the interface pack going to the PCUI. And what we're going to do is actually load something that I could actually demo, the plotter support for this. So first thing I'll show is I started with, let's clear out the program that's in there. We'll start with nothing loaded. So we can see we have full 32K. This has been outfitted with 3 of the memory packs there. So it has a full maximum amount of memory. So what I'll do is I'll load a plotter test program. And if you don't get the file name right, if it doesn't match the both the PB-700 and 770, if the file name here doesn't match the file name we're sending, at the end of the data loading, it'll just basically hang there and it won't actually load it. So this does have to match. So we'll go ahead and load there. And then on the PCUI, I'm going to select the plot tests program C. These are just from the FA-10 manual. We'll select that one. We can see that we're sending it. The header appears, plot test C. It's a program in ASCII mode here. And this takes a little bit of time. So part of the demo here is not just loading the program and showing that it also works on the PB-770, just as it did on the PB-700. I have the PCUI now connected to a serial printer here on the serial port. I also have a parallel printer connected. So this is my Epson thermal receipt printer serial connection, and this is an old dot matrix parallel port connection here. So this is, if it's been a while since you've heard one of these print, stick around. All right. So this should take no more than maybe another minute or so. It's a relatively small program, but again, it's loading in binary mode or ASCII mode. And then what I'll do is I'll save in binary mode. Afterwards, we'll load that because that should load a lot quicker just as a demo. And then we'll test the plotter, just see if that works. So really the PCUI's functionality here with this model and some of the others is cassette loading and saving in all various forms, and then also printer plotter output. So the loading is done. I can go ahead and list the program just to see that we've received all the data. And this is just a simple plotting demo. Okay. And what I'll do is I'll save this in binary mode. And I'll pan over to the PCUI. And for example, that was fairly quick. So we can receive as fast as a calculator can send. So I could also load that. So I'll do new, clear out the program, I'll do load, plot, test, C. We'll do that in binary mode here. And on the PCUI, I'll select, oops, that's data, basic. We'll select the plot test C.bin instead of .text. There it is. So we'll select that. And we could see the header. It's now in binary mode here, which is good. And that's it. So a lot quicker than ASCII mode. ASCII mode is very convenient for typing a program in or scanning or auto, let's see, OCR from the user guide, which is what I did for the FA-10. So within a few seconds, I got all the programs. And then saved them as text files. Shared the PCUI like this USB drive. On my Windows machine, I just put the text files on the drive because this SD card shows up in Windows at this point. And then I could load them directly into the PB-700 or 770 through ASCII mode. And then once I've done that, I could save them as binary back to the PCUI. Now, the interesting thing about the PCUI is it does support tokenization on the fly. So that might be one of the features I add here, where if you send a text file in binary mode, that it would automatically tokenize it on the fly so that you could load it quicker. But just to keep true to the way that this works for now, we'll just, we could load it the slow way. it does work. Okay, so we've loaded the program. I have the PCUI set to output to the serial port here, and I have this Epson receipt printer connected, so I'm going to go ahead and run the program. Before I do that, make sure this is in printer mode. I'll press enter on the PB-770, and we can see that it's running, and the LED flashing is calculator receive, or RX. So and if you notice, the display changed to plotter. So the PB-770, I demoed this in a prior video, once it sends the plotting mode, which is a series of 2 characters that you print out, this recognizes it, switches over to plotter mode, and it's drawing in its internal canvas in the PCUI. So once that's done, this program will turn off plotter mode, which will signal to the PCUI that it should print what's in its buffer. So a few more seconds here, and this will be done. And we'll see the output automatically printed to the Epson thermal printer here. So there are 2 basic modes for printing. There's the plotter mode, which is the FA-10 or FA-11 with the 4-pen plotter, or effectively the other mode is just character mode or line mode, so this will do both. So we can see that the PCUI is now sending to the RS-232 port, so it's printing, and we have ourselves a plot. So this would be what was printed on the FA-10, or plotted, I should say, which would take a considerable amount of time to plot all those circles or draw all those circles. So you could still, with the PCUI, because it emulates the plotter, that allows the programs written taking advantage of the FA-10 will still work well with the PCUI. So as promised, for those that have not heard a dot matrix printer in a while, what I'll do is I will go into the printer menu here. I'll switch it over to Pro Printer. I'll change the port from serial to parallel, and let's turn off the auto form feed. Save some paper. Okay, we'll put this in printer mode. So now the PCUI is directed to the parallel port for printing, which means that it's connected to this dot matrix printer. So I'll go ahead and hit run again. And same thing's happening. This is effectively right now that we know what the output looks like, it's plotting each circle. So every time that light flashes, effectively that's another circle being drawn in the internal canvas. So the reason for the canvas in the PCUI for memory is that these printers can't move the paper forward and back. They're line printers. So effectively what the PCUI is doing is internally in memory, it's creating a PNG image of this, of a canvas of a virtual size. So it's not really bound until the plotting is done. It then knows the bounds. It will scale that image. And then, so it's effectively drawing and emulating the same commands. So if you say draw a circle, the plotter knew how to do that, the FA-10. The PCUI does the same thing. It'll just draw the circle in its internal memory. So when it's done, following all the commands, drawing squares, any commands, any plotter commands the FA-10 supported, this will support. And then it will go ahead and print that canvas out. So we can see that it started printing. Let's see if I could raise this up so we could see it a little bit better. So the printout, the benefit of the PCUI internally drawing this as a PNG, for example, is that it saves that to SD card when it's done. Since it's in a portable format, it can print it to this as a bitmap, for example, or it could send it to a Pro printer, which is an example here. And there it is. This is actually an Oki printer, but it supports Pro Printer emulation. So the PCUI speaks Pro Printer, so it can output in graphics mode like this. This is in 24-pin AGM mode, so there's a lower resolution 8-pin mode that the PCUI supports as well. So there it is. You can print to something modern, something very old, and maybe one day something relatively new, such as a laser printer that's on your network. All right, so the PB-770 works just the same as the PB-700 in terms of the interfacing, so that's a good sign. Good. Surprising that I actually got it right. Unlike the PB-100 series, it took a long time. This was a challenge in many ways as well. So I am glad that that is working. All right, so here's some bonus material here. I have the PB-770 still connected to the PCUI, and what really drove me to get the ASCII mode transfers working is because I took a lot of the programs and the user guides for the FA-10, the plotter printer, as well as the PB-770 manual, the owner's manual. And there was a program at the end, a graphing program, that I didn't really want to type in by hand into the PB-770. So what I ended up doing was using OCR and copying the program from the owner's manual and then putting it on a text file on this SD card and then loading it into the PB-770 or the PB-700, either one. And of course, the binary transfer was mostly working, and then as you saw earlier in the video, not really reliably, and the ASCII mode, which wasn't working at all. Now that those issues have been resolved, I was able to get the program into the PB-770 through the PCUI. It takes about a little over 20 minutes still in ASCII mode. So now that I have it in here, I've saved it in binary mode so that I have it back on the PCUI so I can load it much quicker. And so here's the program running. And I'll put a copy of the output sample up on the video as well, but the idea is you have a menu to input data and correct data, a menu item to graph the data. This exits the program, and then 5 prints the data in a tabular format and then sums it up. So what I'll do is I'll enter data in the same way as the owner's manual example. So in order to do that, I'll go ahead and press 1, and there's not really a fixed limit here. Well, there's a limit in memory, but you could enter as many points within reason. So I'll just enter exactly what is in the user guide as the example. And these are all in increasing order somewhat. Looks like a sales chart demo, for example. Okay. And then pressing enter on a blank line ends the data entry. And there's a couple of things here that I'll point out in running through this program, and every time I run through program examples, I end up having to tweak some of the things in the PCUI. So the first thing is when we hit graph. So if I hit option 3, you could do a band, bar, line, or go back to the menu. So the band output is fairly straightforward. I'll press, well, first I'll put this in printer mode. I'll press 1, and you can see it switch to plotter mode. And when that's done, I'll go ahead and print it. And we're back on the main menu, so I can now print that. Okay, so this is what the band looks like, the chart printed out. So just like the owner's manual, very similar. And then what I'll do is I'll go ahead and I'll select graph again. In this case, I'll do a bar chart. This one takes a little bit longer, but not too long. And then what I'd also like to do, before I print it, I'll go back to graph. I'll choose line. And if we want to draw the line over the previous graph, which happens to be the bar. So I'll press yes. And so now it's going to draw the line on top of the bar chart, which I can now point out a new menu option here. So in my previous demo programs, I include at the end of the program a line to switch back to character mode when in plotter emulation mode. So when the PCUI sees that, it'll print whatever's on its canvas. So that was the trigger before. Now, whenever you're doing graphing or plotting where you want to kind of plot over another plot, I would not put that automatic print feature in, because it would have printed the bar chart and then it would have cleared the canvas and then print the line chart and then clear the canvas. So we didn't want that. We wanted a true overlay feature. So without any modification to the program from the user guide, what I just did is I added a print icon here, a print hotkey. So if the program doesn't automatically send that return to character mode, which would trigger an automatic print, and like you saw with this, where it cuts the paper and prints it, you can do that manually at any time. So I'll go ahead and do that. And we will see the printout here. And we can see, let's see if I can, this is like fax paper here. It's kind of curling up on me. You can see the bar chart with the y-axis labeled and then the line chart on top of it. So that works just like what we see in the user manual in the example. So that worked. I did have to tweak the character spacing, which I'll show an example. The first time I printed it, what was happening was, if you notice this, when the text was rotated, there was extra spacing. So my text over here was moving far into the x-axis here, so there's too much spacing. So when I set the spacing to 0, when it was rotated 0 or 180, it was fine, but 90 and 270 it had spaces in there. So after correcting for that, this is also a bad copy, but you could see same thing happened there. So once I corrected that, the spacing is now correct, which again matches the user guide, the example. And let's see, we'll go back to print. And this time I'll just do, actually we'll go to the main menu, we'll print the data, which is option 5. And again, very similar to the owner's manual there with the spacing, and then it just sums up the total. So yeah, this was a long way to get to the point where I can print this out and print it out to match the owner's manual. So as the demo would have the sample here, and now that they're matching, this is kind of how they laid it out in the user guide. So the plotting, well, again, this is the whole reason I built the plotting emulation feature in the PCUI, and the ASCII mode loading, getting that working, was to get to this point where I could enter in the program, copy the program from the owner's manual, and load it directly into here and run it and come up with the same output. So I would say that's a success for the PB-770 and the PB-700. So I will be releasing the firmware update for these features. Thank you for watching.